So let's learn about something called function composition. So I like to refer to function composition as kind of the fifth operation that you can do with functions. And you've never heard of it before as a fifth operation because you can't really do this with just numbers. So I'm going to write some just kind of like common sense, basic vocabulary, like not super mathy sort of definition down for us. And then we'll kind of go from there with some examples. Okay, so function composition, the way I like to describe it, means that we are going to plug, or that we are plugging one function into another. So if we think of what the word composition means, right? Composition, right, you might think of a composition as like a piece of writing in English class, right? So that's a piece of writing made up of or composed with lots of words, right? But composition often just means like what it's made up of. So function composition is just like two functions that you're putting into each other. So in other words, what this means is that we have nested problems, which just means that there's one inside of the other. Right? And what we're going to do is we're going to solve the inside problem first. And then use that answer to solve the second problem. Now there could be more than two problems. There could be like 3 or 4, right? You can have a ton of function composition going on, but in the most basic sense, there's usually just 2. You do the inside one first, and then you use that answer to solve the second one. So there's a couple of ways that you can notate this, right? So everything in math has its own symbology, right? Its own notation. And there are 2 different ways to notate this. So just like how with function operations, you can put like f plus g inside parentheses and kind of put the function names off to the side, right? You can do the same thing with function composition. So the first way of doing this is in parentheses, we do f and g, and the function composition symbol is an open dot. So we read this as composed with. Right, so the way this reads is f composed with g of x, right? So that little variable off to the side just tells us what the variable is. And this means the same thing as our second way to notate this, which is f, and then like normally it's like f of x like this, but instead of just having an x on the inside, we're going to plug a second function in. So some kind of notes on this notation. I know it looks super funky, but we're going to do some examples and hopefully clear that up. So the inside function, because it's not always easy to tell, the inside function is the one closest to the variable. So in this case, the closest function to the variable for both notations is g. Right? G is closer to x, so g is the inside function. That's where we would start first. In this case, g is obviously on the inside because it's inside the parentheses for f. So let's look at some examples. We're going to do it with a variety of notation and just kind of build into it. So for our first set of examples, we're going to use 2 different functions. We're going to let f of x equal x squared plus 4x minus 5. And we're going to let g of x equal x plus 3. So the first thing we're going to do is just a basic function evaluation. So the first thing I want us to find is f of 2. Right, so to find f of 2, that just tells me I'm going to replace all of the x's in the f equation with a 2. So I'm going to do 2 squared plus 4 times 2 minus 5. Right, so 2 squared is 4, 4 times 2 is 8. 4 plus 8 is 12, minus 5 is going to give me 7. So f of 2 is 7. Right, so there's our first answer. So that was just a basic function question. So now let's actually build in some composition. So for our second problem, I want us to find g of f of 2. So sometimes color coding can really help with this. So I'm going to rewrite this so g is the green function. And inside of that, I want to put the f function. Right, so from part A, right, we know that f of 2 is the same thing as 7. So I'm going to replace this with a 7. So this is really asking me to do g of 7. Right, so you solve the inside problem first. So f of 2 is the inside. We already solved for f of 2. Now we're going to take that answer and plug it into the outside function. So for my g function, right, g is x plus 3. And so for my x value, I'm plugging in a 7. Oops, I said 7 while I was writing it, and that's supposed to be a 3. Right, and then 7 plus 3 is 10. So we're going to say that g of f of 2 is equal to 10. So let's do one more with this set of problems. So we're going to keep with the idea that x is 2, but now we're going to reverse it. So let's write this with the other notation as well. So g composed with f of 2. So f is the whoops, nope, we're going to flip that. We already did that. Whoops. So I'm going to write the word 5. So that reads as f composed with g of 2. So I always like to rewrite this to kind of look more like the second format for the notation. I think that that's much easier to work with. So f is on the outside because it's furthest from the variable, and the g function is closest to the variable. So I'm going to plug the g function in first. So the first thing I have to do is find g of 2 because that's the inside function. So g of x is x plus 3, so g of 2 is 2 plus 3, which is equal to 5. So this is going to become f of 5. So I'm just going to replace g of 2 with its answer, 5. And then I'm going to plug that into my f equation. So my f equation tells me to do x squared plus 4x minus 5. Oops, don't actually need to write the x. And so I'm going to plug in my answer from the first part, so that's a 5. If my Apple Pencil would work, there we go. Right, and now we're just going to simplify this. So we have 25 plus 20 minus 5. So that is going to give me a total of 40. So my answer for this is f composed with g of 2 is equal to 40. Right? So even though we plugged the same x value in for both parts B and part C, right, because the order of the functions is different, right, the total answer is different. So for function composition, right, order matters. That's not the color I want. You can't read that very well. Right, order matters for function composition. Right, we always do the inside first. Okay, so I'm going to throw 2 problems up on the screen, and I want you to try them on your own first, and then I'll go through the answers. So try these on your own, OYO. Right, so for this, I want you to use f of x equals 2x minus 5. And for g of x, we'll use x squared plus 3. So I want you to find 2 problems for me. The first one I want you to do is f composed with g of 4. And the second one I want you to do is g composed with f of 1. So see if you can use those previous couple of examples and try these on your own. So let's go ahead and go over these. So the first thing I'm going to do over here is rewrite this. So it's f composed with g of 4. So g is my inside function, right? And then f is my outside function. Do a little bit of lazy color coding here with Notability. Okay, so the first thing I need to find is I'm going to go off to the side and solve my inside. So I have to do this first. So g of 4 is equal to 4 squared plus 3. So that's 16 plus 3, so that's equal to 19. So I'm going to jump down a couple of lines here. So now I'm going to write that this is really equal to f of 19. Right? I'm just going to plug my answer for the inside function into the outside function. And the f function, it reads 2 times x minus 5. So I'm going to do 2 times 19 minus 5. So 2 times 19 minus 5, that's going to give me 38 minus 5, and that's going to equal 33. So my overall answer is 33. Right? And the second one, the functions are just switched, and I have a different x value. So I want to do this one first. So f of 1 equals 2 times 1 minus 5. So that's 2 minus 5, and that's negative 3. Right, so we're going to go ahead and we're going to say, well, then this becomes g of negative 3. And the g function is just my x squared plus 3. So I'm going to do negative 3 squared plus 3. So negative 3 squared is positive 9 plus 3. So overall, I'm going to get 12. So we can also do function composition where you don't actually have a number in here. So, right, so for both of these, we were given an x coordinate. But we can also do it without giving you an x coordinate. So we're going to use these same functions. And we're going to do function composition with equations here. So for the first problem that we're going to do is I want to find f composed with g of x, right? So now I'm not putting a number there. I'm just leaving it as a variable. So the first thing I'm going to do is I'm going to rewrite this just like we have been. I don't like the first notation as much. I like the second one because I think it shows the inside and outside much clearer. So f is on the outside and g is on the inside. So normally we have an x value to plug in, we plug that into the g function and then take our answer to plug it into the f function. Well, now I know what g of x is equal to, right? G of x is equal to x squared plus 3. So I'm going to go ahead and rewrite this whole thing, right? So I'm going to make this f, and then the answer to the inside function is just the equation of x squared plus 3. I'm going to actually plug in the equation that g is equal to for everywhere I see a variable in x, right? So everywhere I see a variable in x, so right here, right, I see f of x, so 2x minus 5. I'm going to exchange that x for the equation x squared plus 3. Right, so I have 2 times whatever I'm plugging in minus 5, and in this case, I'm plugging in x squared plus 3. So I'm going to go ahead and distribute my 2. There we go. So I get 2x squared plus 6, and then I still have this minus 5 on the end. So I'm going to get 2x squared plus 1 when I combine my like terms, and that's my final answer. Right? So in this case, I'm actually just going to get a new equation. So I'm going to combine 2 different equations and get a third brand new one. Right? So let's see what it looks like if we do it in the opposite order. If I do g of f of x, now g is on the outside and f is on the inside. Right, so all I'm going to do is color code it. And now I know that f of x, right? Scroll up so we can see it, right? It's 2x minus 5. So I'm going to take that g function still on the outside, and now I'm going to plug the equation in on the inside, right? I'm just going to replace f of x with what it's equal to. So now everywhere I see an x in the g of x equation, I'm going to replace that with 2x minus 5. So g of x tells me to do x squared plus 3. And in this case, the x that I'm plugging in is 2x minus 5. So now we want to be really careful with our algebra. So when I have 2x minus 5 squared, that means I actually am going to write it out twice, and I'm going to need to FOIL or multiply or use the box method, however you multiply your polynomials together. So I'm going to use FOIL. So I have 2x times 2x, that's 4x squared, right? And then 2x times negative 5 is negative 10x. Negative 5 times 2x is negative 10x. And then negative 5 times negative 5 is positive 25. And then we still have that plus 3 on the end. And then I'm just going to combine my like terms. So I'm going to get 4x squared minus 20x. Whoops. Try that again. And then 25 plus 3 is 28. So that's going to be our final equation. So we can see just by switching the order, right, we get vastly different equations. So that's why we really want to emphasize that the order matters here. So again, I'm going to give you 2 more to try on your own like this, and then you're going to go practice. Okay, so for your own practice, I want you to let f of x equal negative 3x plus 6, and g of x is going to equal x squared minus 2x. And you're going to do both directions. So the first one I want you to do is f composed with g of x, and then I want you to try g composed with f of x. Okay, go ahead and hopefully you typed in your equation answers or you have them written down on your paper. So let's go ahead and try this. So this is equal to f composed with g of x. And I know what g of x is equal to. So this is going to become f of x squared minus 2x. Sorry about all the annoying color changing. Right, so f of x is just negative 3 times whatever you plug in plus 6. And I'm going to plug in x squared minus 2x. And then I'm going to distribute that negative 3 really carefully. So I get negative 3x squared plus 6x because of that double negative plus 6. And then I don't have any like terms to combine, so I'm actually done. Right, short and sweet there. So now if we do this the other direction, we get g composed with f of x. So that's going to give me g of the f of x equation, which is negative 3x plus 6. And my g of x equation says to do x squared minus 2 times x. So whatever I'm plugging in is going to replace the x. So I'm just going to copy in my equation here. And then we have to be really careful with order of operations and simplifying. So for the first part, I'm going to need to write that out twice so I multiply it correctly. Right? If you practice a bunch, you can actually do it in your head, but if you're not super great at that, don't do it in your head. Right? And I'm going to distribute that negative 2 there, so I'm going to get plus 6x minus 12 on the end. Then if I go ahead and FOIL here, I get negative 3x times negative 3x is positive 9x squared. Right? And then negative 3x times 6 is negative 18x. 6 times negative 3x is negative 18x. And then 6 times 6 is 36. We'll bring down that plus 6x minus 12 here, and then just combine our like terms. So I have 9x squared. So negative 18 and negative 18 is negative 36x, plus 6x is negative 30x, and then 36 minus 12 is positive 24. So that's going to be my final answer.